we shall solve some problems on sequence detectors which are designed using state machines. So, what is FSM? Finite state machines. Now I want someone of you to search about this particular naming. Why it is a finite? Will there be infinite state machines also? ఇలాంటివి కూడా ఉంటాయా?
సార్ ఇన్ఫినిట్ స్టేట్ మెషిన్స్ ఉంటే హార్డ్వేర్ ఎక్కువ అయిపోతుంది సార్, అంత హార్డ్వేర్ ఉండదు.
Then they can simply name it as a state machines, right? Why this particular additional naming?
అందులో స్టేట్స్ అనేవి ఫైనైట్ కౌంటబుల్ స్టేట్స్ కదా సార్ మనకు ఉండేది.
మరి మనకి ఇన్ఫినైట్ లేదు కదా, అలాంటప్పుడు స్టేట్ మెషిన్స్ అనొచ్చు కదా సింపుల్గా. When we don't have infinite, why don't we call it as a state machine simply? Agreed, there will be finite number of states, అందుకే మనం finite state machines అంటాం. అంటే మనకి ఇన్ఫినైట్ స్టేట్ మెషిన్స్ అనేవి కూడా ఏమైనా ఉంటాయా? ఇన్ఫినైట్ స్టేట్స్ అనేది ఏమైనా ఉంటుందా? Once you browse this, we shall have a discussion whenever we have time. Browse this, just browse చేయండి చాలు. మీరేం రీసెర్చ్ చేయాల్సిన అవసరం లేదు, జస్ట్ బ్రౌజ్ చేయండి whenever you have time, whenever you feel interesting. Just try to browse about infinite state machines. ఉంటాయా ఉండవా, ఉంటే ఎలా ఉంటాయి?
సార్
Right.
ఫినిట్ అంటే స్టేట్ మెషిన్స్ అని కూడా అనవచ్చు అంట.
We shall discuss it later. అది పక్కన పెట్టేసేయండి, దట్స్ నాట్ అన్ అంత ఇంపార్టెంట్ ఇష్యూ ఏం కాదు. We shall discuss it later. Okay. Right. Now how to design an FSM for a detection of 3 zeros. ఓవర్లాపింగ్లో ఎలా చేస్తాము, నాన్ ఓవర్లాపింగ్లో ఎలా చేస్తాము. What is the difference that I have told you regarding the overlapping and non-overlapping sequence detectors?
అంటే లాస్ట్ స్టేట్ దగ్గర డిఫరెన్స్.
Right. So the difference is whenever output is equal to 1, so next state, so maybe nearest overlapping state. The concept of a prefix and suffix is to be used here. Prefix, suffix రెండు మ్యాచ్ అవుతున్నాయా లేదా చూసుకోవాలి, and you will be doing it. In non-overlapping, whenever output is equal to 1, the next state will be equal to the reset or the initial state. So initial state helpful. So this is the difference, and the remaining things are the same. Right, a finite state machine for detection of 000. So the first is, let us take some initial state as S0. This is my reset state. In few textbooks it will be mentioned as initial state also, INIT, and represent చేస్తారు. And after that, so the state will be moving on to S1 whenever the input value is equal to 0, for which the output is equal to 0. Now input is equal to 0 is marked here. What about input 1? If input is equal to 1 across S0, what will happen? If input is equal to 1,
నాట్
right, it remains at S0 itself. Why? Because the required sequence is 3 zeros. If it is 1, it remains here itself, right? Now here we are saying that S1 is a state which has detected 0 detect చేస్తుంది. Now after that, after S1, it moves on to the next state, S2. If the input value is equal to 0, and S2 is a state which has detected 0 0. Now after S1, so after S1 is a state, S1 is a state which has detected 0. After S1, if it is 1, what will be the next state?
It's
If
not.
the input is equal to 1, ఏమవుతుంది?
No.
Is not. Why? Because it doesn't matches with the required sequence. Required sequence is 3 zeros. 0 1 will not match, so reset 1 by 0. After S2, overlapping is allowed. So at S2 already 0 0 are detected. If the next input is also 0, next input is also 0, this is to be compared with the required sequence. Is the required sequence. Now try to check the prefix, suffix and prefixes. Try to check the suffix. So దీంట్లో right suffix of this and the prefix of this ఇవి రెండు మ్యాచ్ చేయడం ట్రై చేయండి. So first thing is you are not supposed to check all the 3 bits ని check చేయకండి. Next best చూడండి. So these 2 zeros and these 2 zeros gets matched, right? Match అవుతున్నాయి అవ్వట్లేదా?
Yes, sir.
Right. So the question, so what I am saying is, if the sequence is present in this way, right, and overlapping is allowed, what will be the output for this? Please tell me the output for this. If this is the input sequence, what will be the output sequence where we are trying to check this sequence? So here it will be 0
Zero,
0, right? Good. 0 here, 0 here.
zero,
Now check
Zero.
this. I told you to do it for overlapping case. Overlapping is allowed. So the first, this is 0. So here it is 0. Here it is
One
One.
second. ఇంకా అన్ని one.
right. Then after that, ఇది కూడా 1 అవుతుంది అని చెప్తున్నాం. Why? Because this is using these two. So first, this is the sequence. The next sequence is this. The 2 zeros are used here. So 2 zeros use అయిపోయినాయి అంటే are do we check those 2 zeros again? మళ్ళీ 2 zeros చెక్ చేయాలా ఓవర్లాపింగ్ లో? ఓన్లీ థర్డ్ జీరో చెక్ చేస్తే సరిపోతుంది కదా.
Yes, sir.
Overlapping is allowed. So we don't check those 2 zeros again. See here also the same thing will happen. So these 2 zeros followed by this, and now the answer will be equal to 1 here. Now again these 2 zeros, answer will be equal to 1 again. These 2 zeros, answer will be equal to 1 again. Now tell me what should be the next state here? S2 తర్వాత next state ఏం అవ్వాలి? S1 అవ్వాలా? S2? Why S1? Please tell me.
S2, sir.
So it should be S2. Again it should move back to the state. Already 0 0 match అయిపోయింది కదా. So 0 0 match అయిపోయింది. Now we are supposed to a state కి వెళ్ళాలి. A state which has already detected 0 0. 0 0 ఏదైతే చెక్ చేసిందో స్టేట్, ఆ స్టేట్ దగ్గరికి మనం మూవ్ అవ్వాలి. And that particular state is nothing but S2. S2 is a state which has already detected 0 0. So next ఇంకో 0 వచ్చిందంటే, so output will be equal to 1. That's it. If we are moving on to S1 కి మూవ్ అయిపోతే నెక్స్ట్ ఇంకా 2 బిట్స్ సెట్ చేయాలి. S2 కి వెళ్తే 0 0 చెక్ అయిపోయినట్టు. వాట్ ఇఫ్ ఇన్పుట్ ఇస్ ఈక్వల్ టు 1 ఆఫ్టర్ S2? ఇన్పుట్ 1 అయితే ఏంటి?
Please.
Right. So if it is 1, it resets reset condition 1 by 0. Right. Perfect. Now for overlap condition, S0 will move to S1. when this will happen. So whenever input is equal to 0, and if input is equal to 1, it remains in the same reset state. అక్కడే ఉండిపోతుంది 1/0. After S1, if it is 0 again, if it is 0, output is equal to 0, it moves to the next state, S2. And if it is 1, it gets reset here after S2. Now tell me what will happen after S2 if input is equal to 0, ఏమవుతుంది?
Same as today.
Reset.
Reset. Say this non-overlapping condition. When output is equal to 1, please reset your circuit. That is the definition. So 0/1. 0/1 వస్తుంది. And if the input is equal to 1, what will happen?
సేమ్ సార్ 1/0 అప్లై
Right, 1/0. Same loop మీద 1/0 రాస్తాం. You need not draw another loop. Another loop is not required. So this is what the problem is. I'll write you the sequence also. Any random sequence. If the input sequence is present in this manner, 1 0 0 1 0 0 1 0 1 0, and this way. The input sequence here also the same sequence will be taking here also. 1 0 0 1 0 1 2 3 4 5. Now the output for this case, sequence detector output. So here it will be 0 0 0 and again 0. This is 0, this is 0. So 0 here, 0 here, 0 here, and after that, now here this will be 0. So this is 0, and here we will be getting 1. 1 వచ్చేసింది. Now overlapping case. So these 3 zeros. So here again we will be getting 1. Now with these 3 zeros, here again we will be getting 1. Output for non-overlapping case. So 0. This is 0. This is also 0. Now tell me what will happen next.
1 సార్
తర్వాత ఏమవుతుంది? 1 వస్తుందా రాదా? నాన్ ఓవర్లాపింగ్ కేస్. సో అగైన్ రీసెట్ అవుతుంది. రైట్, పర్ఫెక్ట్, 0. So after a sequence has been detected, or whenever output is equal to 1, reset అంటే మళ్ళీ బిగినింగ్ వెళ్ళిపోయింది. So here it is 0, here it is 0. If there is another 0, then output will be equal to 1. So if there is another 0 here, so if you place another 0 here, then my output will be equal to 1. So output will be equal to 1. So this is the difference between overlap sequence detectors and non-overlap sequence detectors. Then after that, so what you will be doing? What will be the next step in designing of circuits?
నెంబర్ ఆఫ్ ఫ్లిప్ ఫ్లాప్
So the next is state assignment. How many states are present here? 3 states, S0, S1, S2. So you may assign it randomly. Let it be 0 0, let this be 0 1, and let this be 1 0. Now after state assignment, what will be the next step in design?
నెంబర్ ఆఫ్ ఫ్లిప్ ఫ్లాప్
State transition table. So in state transition table, so each state is represented with 2 states, so 2 bits. So how many flip-flops are required? How many flip-flops are required here? 2. Q1, Q0. Input is of 1 bit X. Q1 plus, Q0 plus. Output is represented with some Y. Output is represented with Y. Output is represented with Y. Then after that, the flip-flop inputs, which may be D1, D0 or T1, T0 or JK. See, output low, present out only state slow matrame. So we will be having present state and next state. So for outputs, we won't have present output, next output ఇలాంటిది ఏవి ఉండదు. Don't get confused here. States కి మాత్రం present state, next state అని చెప్పేసి రాస్తాము. Output లో మాత్రం will be having only one particular output which will be based upon Q1, Q0 and inputs. So if you write in this way, so it will be wrong. Only states కి మాత్రం present state, next states అని రాయండి. Output కి present output, next output అని చెప్పేసి రాయకండి. State transition table. So here, so the formulation of this particular table. For this also the same steps. So here also state assignment. State assignment S0, S1 and S2. Then after that, state transition table. So where we'll be marking the present states, input, next state, output and flip-flop inputs. Then after that, after this circuit diagram, right?
సార్
Yes.
అంటే ఫర్బిడింగ్ స్టేట్స్ ఉంటాయి కదా సార్ ఇక్కడ రెండు, వాటిని ఏం తీసుకోవాలి సార్? అంటే 0 0 అని
don't guess. Reset తీసుకోండి. Reset condition.
అవుట్పుట్ కూడా 0 తీసుకోవాలి కదా సార్?
అవుట్పుట్ 0 తీసుకోవాలి. Right. So circuit diagram, expressions, after expressions it is circuit diagram. This is so whenever we are solving the problems related to sequential detectors. Now suppose we are doing the same thing in tool, in VLSI, electronic design automation tools, which may be Xilinx or Cadence or anything else, which based upon Verilog, Couch or VHDL or else Python or C, any hardware description language. So there what will happen is, there you won't be doing all these particular steps. There your first step what you will be doing is state diagram. State diagram is to be drawn by yourself based upon the given problem specifications. This is based upon problem specs. Problem specs ni base cheskoni mere state diagram ni analyze cheyali. Then after that, state assignment will be done by you. State assignment is also done by you. Then after that, you may perform state reduction also. If there are any redundant states, you may perform state reduction or state minimization under దీన్ని కూడా. So this is also called as state minimization. Then after that, so what people will be doing is, so mostly we do go for behavioral code of Verilog or VHDL. So దీంట్లో switch case condition. Do you remember the switch case condition in C programming? C programming లో గుర్తుందా మీకు? C programming లో switch case conditions. So based upon that, so the problem will be solved. And another method is after state minimization, state table, then after state table, expressions, after expressions, using data flow modeling of Verilog, you may do it. Is the next method. And one more method we have after expressions, and draw the circuit diagram, gate level circuit diagram, and then using gate level modeling of Verilog, problem will be solved. So these are the three different ways. So which is the best, which is the simple way, which method will be used in most of the cases? ఏది చూస్ చేసుకుంటారు ఎవరైనా? This is one. So behavioral code. So if this is a 2 and this is 3, most of the people, most of the industries, they will be using this particular thing. Behavioral code. Simple గా స్టేట్ మెషిన్ డ్రా చేస్తారు. State machine based for the state machine, state assignment, state reduction, and switch case condition based చేసుకొని program రాస్తారు, and the program is going to give you the circuit. అదే సర్క్యూట్ ఇస్తుంది, ఇంకా అదే సర్క్యూట్ ఇస్తుంది, రైట్? Is it clear for everyone?
Yes, sir.
Right, now design a circuit for detection of 111 or 000. So this is a sequence detector finite state machine. This is a sequence detector finite state machine circuit. For this, so the input and outputs are of 1 bits. Now in some textbooks, it is also named as 2 input 2 output system. Itla kuda icharu names. That is, the input may be 0 or 1, or maybe either 0 or 1. At a time can give 0 or 1 ఇవ్వచ్చు. So 2 input 2 output system అంటున్నాడు. In some textbooks, this particular terminology is also used. A 2 input and 2 output system. Two input, 2 output system. It is not, I mean, don't get confused here. 2 inputs ante malli 2 bits అనుకోకండి. అది 1 bit మాత్రమే. Either 1 or 0 ni 2 input అని చెప్పేసి అన్నాడు. Right here, so whenever the sequence is either 111 or whether the sequence is 000, output must be 1. And do it for both overlap case and non-overlap case. Now please draw the state diagram for this. Please draw the state diagram for this. Detection of a single state diagram. The single state diagram should be capable of detecting either 111 or 000. Two different state diagrams kaadu. So we have seen two different state diagrams. How to detect 000 on a state diagram already man draw chesamu. We have analyzed that also. 111 is also known for us. Now I want a state diagram which is going to detect both 111 or 000. So string of 3 bits pass అయినప్పుడు whenever it consists of 000 or 111, output must be equal to 1. Is the question clear for you? Is the question clear for you? If it is in this way 01010 00 111 and 0000 1111 000. Two paths use చేయాలి కదా. Definitely you need to use two paths. See, the answer should be in this way. Whenever it is 0, it is 0, 1. For 1 also it is 0. Here also this is 0. Here also this is 0. Here also this is 0. Now for this 0, 0, and here this is equal to 1. Detection of 000 detect చేస్తుంది. Now the same circuit. So whenever it is 1, it is 0. 1, it is 0. It is 1. 3 ones 1. 3 ones వచ్చినాయి 1 వచ్చేస్తుంది. Now here it is 0, here it is 0, here it is 0, and hence it is 1 3 zeros. Now suppose if overlapping is permitted, there is 3 zeros. This will be 1 here. So this is 0, this is 0, this is 1, and again if overlapping is permitted, this is 1 here, and next is 0 0 and 0 for overlapping. Now so we are supposed to design this particular circuit. Hardware దీనికి డిజైన్ చేయాలి. 3 zeros వచ్చినా కానీ 3 ones వచ్చినా కానీ output must be equal to 1. Output must be equal to 1. How you will draw this? Try this. Yes, tell me. చెప్పండి.
కొన్ని ఎక్స్ట్రా స్టేట్స్ యూస్ చేస్తే సరిపోవచ్చు. అంటే ఫస్ట్ 11 ని డిటెక్ట్ చేసి తర్వాత 00 ఇంకో పాత్ వెళ్ళిపోతే సరిపోతుంది.
అంతే. At a time it is going to detect both the paths. S0 is a reset state. S0 is a reset or initial state. Now in this maybe 5 state route,
5 states వచ్చేసి
it moves on to S1 if it is 0 by 0. S1 is a state which is remembering 0. Now if it is 1, output is again 0. It moves on to state S2. Now S2 is a state which is remembering 1. Is this clear? Ikkadi clear?
Yes, sir.
Right, then after that, so from S2, if it is 0 again, 0 by 0, it is moving on to S3. S3 కి వెళ్ళిపోతుంది. Then from S2, if it is 1, output is 0. S4, it is moving on to S4, and from S4, now we need to check whether we are drawing the circuit for overlapping or non-overlapping. First, let us take the case of non-overlapping. Non-overlap first తీసుకోండి. After S4, if the input is equal to 1, it goes to the reset condition. ఏమవుతుంది ఇక్కడ 1 by 1 అవుతుంది. After S3, if the input is equal to 0, 0 by 1 అయిపోయింది. Now the next is after S1. After S1, if input is equal to 1, what will happen?
S2 sir.
If input is equal to 1, reset చేయాల్సిన అవసరం
Yes.
లేదు. So it
S2.
moves on to S2. It moves on to S2. S2 అంటే 1 డిటెక్ట్ చేస్తుంది కదా. And here also we have a single 1. So 1 ఎక్కడ ఉందో అక్కడికి వెళ్ళిపోతే చాలు, రీసెట్ అవ్వాల్సిన అవసరం లేదు. హియర్ వీఆర్ డిటెక్టింగ్ 000 అండ్ ఆల్సో 111 సైమల్టేనియస్లీ, రెండు సైమల్టేనియస్ డిటెక్ట్ చేస్తున్నాం. సో ఫస్ట్ ఇప్పుడు 0 వచ్చింది అనుకోండి, నెక్స్ట్ వాట్ ఈస్ ద ఎక్స్పెక్టెడ్ వాల్యూ? ఏం ఎక్స్పెక్ట్ చేస్తుంది? 0 ఈజ్ రిమెంబర్డ్. అగైన్ ఇట్ ఎక్స్పెక్ట్స్ 0 వస్తుందేమో అని ఎక్స్పెక్ట్ చేస్తుంది. సపోజ్ 1 వచ్చింది. So if 1 has arrived, what will be the next expected value, input value? So again it expects for 1. So a 1 ఇక్కడ detect అయిపోయింది. So that is the reason I am saying, so whenever after S1 state, if input is equal to 1, it moves on to S2, because S2 is a state which has detected the presence of 1. S2 already detect చేస్తుంది కాబట్టి అక్కడికి వెళ్ళిపోతే సరిపోతుంది. Now after S3, if the input is equal to 1, what will happen? So this is 0 0 detection, 0 0 detection. After S3, again it moves on to S2 only. So 1 by 0, 1 by 0. Now tell me, across S2, if the input is equal to 0, what will be the next state?
S1.
Right, perfect. So this is 0 by 0. Now after S4, if input is equal to 0, what will be the next state?
Again S1.
So again it will be S1 only. If input is equal to 0 by 0. Right, have we covered all the sequences? I mean all the combinations? అన్ని కాంబినేషన్స్ అయిపోయినాయా? ఏమైనా ఉన్నాయా? Across each state, have we covered 0 and 1? Right, I think we have covered all the conditions. So now here, how many states are present? State assignment is the next.
5.
Right, state assignment. So we have 5 states, which are nothing but S0, S1, S2, S3, S4. Now we can assign in this way: 0 0 0 0 1 0 0 1 1. So here for this 0 0 0 1 0, and for this 1 0 0. So you can do it randomly చేసేయండి. So it is sufficient. Non-overlapping case. This is non-overlapping case. We shall do it for the overlapping case also. For overlapping case, S0 is my initial state. S0 is my initial state. If it is 0 by 0, I am moving on to S1. If it is 1 by 0, I will be moving on to S2. Now S1 is a state which has detected 0, and S2 detected 1. After S1, so if it is 0 by 0, it moves on to S3. After S2, if it is 1 by 0, it is moving on to S4. Now after S3, if it is 0 again, what will be the next state? So S3 is a state which has detected 0 0. So if it is 0, the next state will be the same. అక్కడే ఉండిపోతుంది, 0 by 1 అవుతుంది. 0 by 1. Now after S4, the S4 is a state which has detected 1 1. If the next input value is equal to 1, what will happen?
S4 1 by 1.
Same state, S4 లోనే ఉంటుంది. 1 by 1, 1 by 1. Right. Now S1, what about S1? After S1, if input is equal to 1, so it moves on to S2. This is 1 by 0. Next, after S3, if input is equal to 1, what will happen?
S2, sir.
S2, sir.
It moves on to S2. This is again 1 by 0. Now after S2, if input is equal to 0, what will happen?
S1.
S1, sir.
Right. So this moves on to S1. This is 0 by 0. Now after S4, if it is 0, what will happen?
S1, sir.
Answer.
Right. S1, 0 by 0. Perfect. Then for this also the same, the state assignment, after state assignment, state transition table, and then the state diagram with the help of the expressions. Now, are this clear for everyone? Are this clear for everyone? Right. So the question will be asked in this way. This is how the question is asked. The question alone. I haven't used the terminology. The terminology is present here. The standard terminology is present here. A clocked sequential circuit is provided with a single input X and a single output Z. Now single input X, this can be either 0 కావచ్చు 1 కావచ్చు. Single output Z, it can be either a 0 or 1. Now whenever the input produces a string of pulses, triple one or triple zero, triple one or triple zero, at the end of the sequence, it produces an output Z is equal to 1. So 0 0 1 output రావాలి. దీనికి 0 0 1 output రావాలి. And with overlapping. With overlapping. We have done it just now. Is this clear? Have you understood the question? We have already done the answer for this. Right. Now, if you have done it, can you do this? Design a 2-input, 2-output synchronous sequential circuit. Design a 2-input, 2-output synchronous sequential circuit which produces an output Z is equal to 1, which is producing an output Z is equal to 1. Output Z is equal to 1. So whenever any of the following input sequences 1100 or 1010 or 1001 occurs and the circuit resets to initial state after one output has been generated. Is it an overlapping or non-overlapping case? The overlapping or non-overlapping?
No overlapping.
Right. Perfect. So this is a non-overlap sequence detector. Now can you do it? చేయగలరా? Try it. I'll give you 3 minutes time. Single state diagram. Don't draw 3 different state diagrams. 1100 ko state diagram, 1010 ఒకటి, 1001 కి 3 state diagrams draw చేయకండి. Draw a single state diagram which is going to detect whether the given sequence is 1100 or 1010 or 1001. If you have done it, please post a message saying yes. Manohar has done it. I too will try it. So you please verify your answer, whether it is right or wrong. I'll do it here. Initial state is S naught. Initial state is S naught. A reset state or initial state. Now S naught will move to state S1 for what input? 1 or 0? ఎప్పుడు వెళ్తుంది? For 1. Right. So see the sequence, 3 sequences చూడండి. So in 3 sequences, the first bit is the 1. First bit is 1. So the first bit 1 ఉండాలి. Now suppose if the first bit itself is 0. First bit itself is 0. What will happen? So simply reset. So first bit, if it is 0, reset 0 by 0, right? Now S1 is a state. So S1 is a state which has detected 1. S1 is a state which has detected 1. Now next. So next, see the sequence properly. So here we have 1 over here, and we have zeros in this case. So after S0, so 1 is a valid sequence and 0 is also a valid sequence. So let us do it in this way. If it is 1 by 0, it shall move on to S2. Rendu valid. So input 1 is a valid, input 0 is also valid. If it is 0 by 0, it moves on to S3. Is it clear? Is it clear? Right. Now S2 is a state which has detected S2 is a state which has detected 1 1. S2 is a state which has detected 1 1, and S3 is a state which has detected 1 0. 1 0 detected. Now after S2, if the next input value is 0, if the next input value is 0, 0 by 1, I shall move on to S4 కి వెళ్ళిపోతాం. Then it is 1 1 0 అయిపోతుంది.
0 by 0 కదా సార్.
Right, it is 0 by 0. It is not 0 by 1, it is 0 by 0. Right, okay. Now, after S2, if it is 1, what will happen then?
S2
If it is 1, what will happen then? S2 will remain in the same state. ఇక్కడే ఉండిపోతుంది. It will not move to S1. S1 కి వెళ్ళదు. S2 దగ్గర already 2 bits match అయిపోతున్నాయి కాబట్టి it remains at S2 itself. So it will be 1 by 0. 1 by 0. Right. Right. Now after S3, if the next input is equal to 0, if the next input is equal to 0, see, here again we have 2 valid sequences. If it is 0, it shall move to a state S5 కి వెళ్ళిపోతుంది. The state which is detecting 100. So 100 is a valid sequence. We require 100 కావాలి. Next, after S3, if the input is equal to 1, it moves on to S6. This is also a valid sequence. 101, this is a valid sequence. Is it clear till then, till now? Ikkada clear?
Yes.
Right. So valid sequence అయితే ముందుకెళ్తుంది, invalid sequence అయితే బ్యాక్ వెళ్ళిపోవడమో సేమ్ లూప్ లో ఉండిపోవడమో జరుగుతుంది. So this is an invalid sequence. So this is an invalid sequence. So అక్కడే loop లో ఉండిపోయింది. This is also an invalid sequence. Stayed in the same loop. Right. After S4, if the input is equal to 0, at S4, what is happening at S4? We are having 110 sequence. ఈ 110 sequence ఉంది. If the next input is equal to 0, what will happen?
Reset.
Reset.
Reset అయిపోతుంది. Right. Output will be equal to 1 and reset condition. So
S5 కి వెళ్ళడానికి ఏం అవసరం?
right. So what is our question? The circuit resets to its initial state after a one output has been generated. The circuit resets to its initial state after a output 1 has been generated. సో ఎప్పుడైతే అవుట్పుట్ 1 అవుతుందో అప్పుడు కంపల్సరీ రీసెట్కి వెళ్ళిపోవాలి. యాజ్ పర్ ది క్వశ్చన్, ఇస్ ఇట్ క్లియర్? క్వశ్చన్ ప్రకారం వెళ్ళిపోవాలి. యాజ్ పర్ ద స్పెసిఫికేషన్ బేస్ చేసుకొని. సో హియర్ అవుట్పుట్ ఈజ్ ఈక్వల్ టు 1 కాబట్టి రీసెట్కి వెళ్ళిపోతుంది. రైట్. Now suppose if this input bit is not 0, if the input bit is equal to 1, so 110 and input is equal to 1. Now what will happen now? ఇప్పుడు ఏమవుతుంది? Output is not equal to, so see here output is equal to 1, reset అయిపోయింది. Here output is equal to 0 and no reset here. Reset అవ్వాల్సిన అవసరం లేదు. So yes, perfect. S6.
Yes, sir.
Now this 1101 will be mapped with, దీంతో మ్యాప్ చేద్దాం. 1100 తో మ్యాప్ చేయండి, నెక్స్ట్ 1010 తో మ్యాప్ చేయండి, అండ్ ఆల్సో మ్యాప్ విత్ 1001. Now prefix suffix condition చూడండి. So here the suffix is 101 is the suffix. Now this is what? This is not 101 and this is 101. It is matching here. ఇది 100 కాదు. Now we are supposed to move on to a state which is having 101. So 101 ఎక్కడ ఉందో అక్కడికి మూవ్ అయిపోవాలి. Where do we have 101?
S6.
Right. So move on to S6. Move on to S6. What is the input combination? 0 by 0. S6 కి ఎందుకు వచ్చింది అంటే output is not equal to 1. If output is equal to 1, we are supposed to move to reset condition. Right. 1 right, 1 by 0. It's 1 by 0.
1 by 0.
Right. Okay. So it is 1 by 0. Right. Fine. S4 అయిపోయింది. Now across S5, let us check across S5 what is happening across S5. Now across S5 100 condition. After 100 S5 100, if the next input is equal to 1, what will happen?
Reset.
Right, perfect. Output is equal to 1 and hence reset condition. So from S5, see whenever you are drawing the state diagrams, please check that there won't be any overlaps. ఇలా వైర్ నుంచి ఇలా రాకుండా ఉండడానికి ట్రై చేయండి. So 1 by 0, sorry, 1 by 1. 1 by 1. Now what happens if the input is equal to 0? Input is equal to 0 అయినప్పుడు ఏమవుతుంది? So 100,
Reset.
మ్యాచ్ అవ్వదు కాబట్టి రీసెట్.
right, it won't match with any of the sequence. దేంతో కూడా మ్యాచ్ అవ్వదు. 1101 1100 1010 1001. So it won't match. Even a single bit will not match and hence go to reset. So the same line 0 by 0, 0 by 0. And now you check with S6 చూడండి. S6. After S6, if it is 0, what will happen? State S6 101. If it is 0,
Reset.
reset condition. Output is equal to 1. Right. 0 by 1, right? Now if it is 1, what will happen?
It's to
1 0 1 1. 1 1 will
S2.
match with 1 1 1 1
S2.
S2, right? S2, move to S2. One by 0. Is this clear? So మీకు సేమ్ స్టేట్ డయాగ్రామ్ రావచ్చు రాకపోవచ్చు. Why? Because you might have taken S2 plus to S3 తీసుకోవచ్చు, S3 plus to S2 తీసుకోవచ్చు. So your own wish. So diagram same గా రావాలని ఏం లేదు, but you need to check whether the sequences are proper or not. This sequences check చేసుకుంటే సరిపోతుంది. Now how many states are there? Total number of states. Total number of states will not vary. Total number of states will be the same. So how many states are here? Total states,
7.
7.
right? Total states are 7. How many flip-flops are required?
3, sir.
3 flip-flops are sufficient. So you may assign in this way. So S0 may be assigned as 000. S1 may be assigned as 001. S2 may be assigned as 010. S3 may be assigned as 011. S4 may be assigned as 100. S5 101. S6 110. This is how the state assignment will be done. Then after this, state transition table, circuit diagram, and so on. This is regarding this problem. Is this clear? Is this problem clear for everyone? Detection of multiple input sequences. Multiple input sequences. Non-overlapping condition chaser. Can everyone see this problem? Is this visible? Problem 1.
Yes, sir.
The problem 1 says that for each of the following finite state machines, please indicate if they are or not well formed. Note that the state names have been omitted for clarity. So because state name, you need not consider this. State name, you need not consider this. You may assume the state names are unique. So the state name X ankondi, state name Y ankondi, state name Z ankondi. So this is X, the Y, the Z, the W, the P, the Q, the R. Right. So finite state machines worksheet. So this is taken from MIT course. So ఈ కోర్స్ నుంచి తీసుకున్నది, రైట్? నో ఆన్సర్ దిస్, ఆన్సర్ చేయండి.
ఒక బి ఒకటే సరిగ్గా ఫామ్ చేస్తాం. అవుట్పుట్
Only B is the proper, huh? Right. So the first is it is whether it is well formed or not well formed. How we are saying, how we are supposed to say ఎలా చెప్తాం? Whether it is well
output to input
formed.
transition.
1 or 0.
So the first condition is for every state S0, S1, S2, so on, Sn, input combination, input sequence should be properly mentioned. Suppose if input is of 1 bit X ankondi, then for 1 what will happen? For 0 what will happen? Next state ఏమవుతుంది? అండ్ S1 దగ్గర x ఉంటాయి. సో 1కి నెక్స్ట్ స్టేట్ ఏంటి, 0కి నెక్స్ట్ స్టేట్ ఏంటి. అండ్ సపోజ్ if the x this is of 2 bits, x1 x0 ఉంది, then how many conditions should be mentioned? Next state for 0 0 ఏమవుతుంది, next state for 0 1, next state for 1 0, next state for 1 1. All these things should be mentioned properly. This is the first condition. ఇది ఫస్ట్ కండిషన్ అనుకుందాం. నెక్స్ట్ కండిషన్ is outputs. So whether it is a mealy machine or more machine, if it is a more mealy machine, outputs should be mentioned across each and every input. Input రాసిన దగ్గరే output కూడా రాయాలి. If it is a more machine, outputs will be associated with states లోపల ఉంటాయి. Right, first let us check the first condition. Check చేయండి. Let us check the first condition. The condition 1 is all the set of inputs అన్ని కూడా మార్క్ చేశారా చేయలేదా. So from the diagram it is clear that input is of 1 bit or 2 bit.
1 bit.
Right, from the diagram it is clear that input is of 1 bit. Input is of 1 bit. Now if check చేయండి ఏమవుతుందో. Across this state, if this state is assumed as x, after x, if it is 0, it will move on to this state, and ఇది y అనుకోండి, ఇది z, and let it be w. If it is 0, it is
స్టేట్స్ అనుకోకుండా అవుట్పుట్స్ కూడా అనుకోవచ్చు కదా సార్.
రైట్, అవుట్పుట్స్ కూడా అనుకోవచ్చు. సరే అవుట్పుట్స్ అనుకోండి, అండ్ స్టేట్ నేమ్స్ కూడా ఉన్నాయి అనుకోండి. Then you may take it in this way. ఇలా తీసుకోండి. x by 1 అనుకోండి, y by 0, w by 1, some p by 1. Is it clear now? స్టేట్ నేమ్ x అనుకోండి, ఆ స్టేట్ లో ఉన్నప్పుడు అవుట్పుట్ 1 ఉంది అనుకోండి, y అనుకోండి 0 ఉంది, p ఉంది 1 ఉంది, w and 0. Right, okay. Now after x, 0 is mentioned and 1 is mentioned. Okay, perfect. X proper ga undi. Now after y, are the two states mentioned properly?
ఎస్ సార్.
So 0 is mentioned and also 1 is mentioned. So after y also it is okay. So after w,
Yes, sir. Both are mentioned.
both are mentioned. After p,
No, sir.
right, it is wrong. See this. So 1 ఉన్నప్పుడు సేమ్ స్టేట్ అన్నాడు, 1 ఉన్నప్పుడు y కి వెళ్తుంది అంటున్నాడు. He is saying that so p will move to state y and also p will move to the same state p whenever input is equal to 1, and whenever input is equal to 0, it is moving on to the state x, which is ambiguous, and hence this is wrong. This is not well formed. Right, finite state machine b. State machine b చూడండి. If this is x, so this is y, this is z. Now can you tell me the reason for that? So for x,
ఎస్ దగ్గర 0 సేమ్ ట్రాన్సిషన్ కి
right,
సేమ్ ఇన్పుట్ కి డిఫరెంట్ స్టేట్స్.
right, okay. So across z, so if it is 0, output is equal to 1. If it is 1, output is equal to 0. Okay kada? What's wrong?
సరిపోయింది.
What's wrong in that? Different outputs ఉండొచ్చు కదా. Serial adder, we got different set of outputs. Right. So at x, so the next state is defined, and for 0 it is defined, for 1 it is defined. Okay, outputs are also defined. For y, for 0 it is defined, for 1 it is defined. What about z?
కూడా డిఫరెన్స్.
So for 0 it is defined, for 1 y also it is defined. then it is okay, right? Okay kada?
Okay, sir.
Y by 1, Z by 0. Now tell me, what about C? What about C?
Sir, y కి జీరో ట్రాన్సిషన్ లేదు.
Right. So across X we have, so 0 condition is there, 1 condition is there. Now across Y this is there. For 1 it is mentioned, for 0 it is not mentioned, and hence it is not well formed. It is not well formed.
Sir?
Yes, tell me.
సార్ మనం ఆ డయాగ్రామ్స్ మీద బేస్ చేసుకుని డైరెక్ట్ గా చెప్పేయచ్చు కదా సార్.
అలానే కదా ఇప్పుడు మనం చెప్పింది.
సార్ అంటే 1 బిట్ కాబట్టి 2 స్టేట్స్ ఉన్నారు కదా సార్, సెకండ్ మాత్రమే ఉంది, మిగతా వాటికి లేదు కదా సార్.
అలానే కదా మనం చెప్పింది.
ఎస్ సార్, ఎస్ సార్, అర్థమైంది సార్.
Right. See, so మీ అందరికి ఎక్స్ప్లెయిన్ చేశాను. those who are quick, so just by seeing you can put the answers. ఇలా అనలైజ్ చేయాల్సిన అవసరం లేదు, జస్ట్ చూసేసి మీరు ఆన్సర్స్ పెట్టచ్చు.
సార్ సెకండ్ బి, సార్ బిలో వై అనే స్టేట్ ఎగ్జిస్ట్ అవ్వదని చెప్పొచ్చు సార్, అంటే ఇన్పుట్స్ ఏం లేవు కదా సార్ అక్కడ.
ఇన్పుట్స్ లేకపోవడం ఏంటి?
అంటే ఆ స్టేట్కి రావట్లేదు కదా సార్, అంటే ఎక్స్ నుంచి కానీ జెడ్ నుంచి కానీ.
రావాల్సిన అవసరం ఏముంది? అక్రాస్ ఈచ్ అండ్ ఎవ్రీ స్టేట్ వి ఆర్ సపోజ్ టు డిఫైన్, రైట్? అది డిఫైన్ అయిపోయింది కదా.
ఓకే సార్.
అంటే డిఫైన్ అయిందా లేదా చెక్ చేసుకోండి, ఎక్స్ నుండి ఎక్కడికి వెళ్తుంది. సో అక్రాస్ ఎక్స్ వీ హ్యావ్ 2 స్టేట్స్, 0 మెన్షన్ అయ్యి ఉంది, 1 మెన్షన్ అయ్యి ఉంది. అక్రాస్ వై ఇట్ ఈస్ మెన్షన్డ్, అక్రాస్ జెడ్ ఆల్సో ఇట్ ఈస్ మెన్షన్డ్. రైట్, మేబీ ఇలా ఉండి ఉంటుంది కదా స్టేట్ డయాగ్రామ్, ఇలా ఉండి ఉంటుంది. ఎక్స్ జెడ్ వై, దాని తర్వాత ఇక్కడ లూప్ రావట్లేదేమో. లూప్ బ్రేక్ అయిపోతుందేమో.
సార్ అంటే అక్కడ ఓవర్లాప్ కండిషన్ ఎగ్జిట్ అయింది అనుకోవచ్చు సార్ మనం.
సీక్వెన్స్ డిటెక్టర్స్ కాదు ఇది, సింపుల్ స్టేట్ డయాగ్రామ్ అంతే. ఒక స్టేట్ డయాగ్రామ్ లో అన్ని ఉన్నాయి, ప్రాపర్ గా ఫామ్ చేశారా, ప్రాపర్ గా ఫామ్ చేయలేదా అని మాత్రమే అడుగుతున్నాడు. నథింగ్ టు డూ విత్ సీక్వెన్స్ డిటెక్టర్స్. కావాలంటే అనుకోవచ్చు నాన్ ఓవర్లాపింగ్ అనుకోవచ్చు, ఓవర్లాపింగ్ అనుకోవచ్చు, but this has nothing to do with sequence detectors. This is not a sequence detectors example. This has nothing to do with sequence detectors. జస్ట్ ఒక స్టేట్ డయాగ్రామ్ ఇచ్చాడు, ఆ స్టేట్ డయాగ్రామ్ ప్రాపర్గా ఉందా లేదా చెక్ చేయండి అన్నాడు. దట్ వి ఆర్ హియర్, దట్స్ ఇట్. ఓన్లీ స్టేట్ డయాగ్రామ్ అలానే చూడండి, స్టేట్ డయాగ్రామ్ లానే చూడండి.
ఓకే సార్.
ఓన్లీ స్టేట్ డయాగ్రామ్ లానే చూడండి. రైట్. Now see this question. This is a different set of question. The work on this question. So draw the state diagram and the state table of a 2 input 2 output synchronous sequential circuit. 2 input ante malli confuse avoddu. So it is only of 1 bit. Input is only of 1 bit. 2 input in the sense either it is 0 or 1 antunnadu. It may be either 0 or 1 input. That's it. This is of X and this is Y. 2 input, 0 or 1. Right. So the question is a synchronous sequential circuit which examines the input sequence in non-overlapping strings. Non-overlapping sequence detector. Strings of 3 inputs each. 3 inputs. Sequence of 3 inputs. Sequence of 3 inputs. and produces a one output coincident with the last input of the string, if and only if the string consists of either 2 or 3 ones. If the string consists of, if this particular string, idoka string, this is a string, is string low, if and if only if there are 2 or 3 ones, then my output is equal to 1, or else my output is equal to 0. And he has also given one example also, 0 1 0 1 0 triple 1 0. This is the input sequence. Expected output is, this is 0, this is 0, and this is 0. It is first string. Now here this is 0, this is 0. What about the output here?
1, sir.
1, sir.
Right, 1. Why? Because we have 2 ones.
1.
Right, next this is 0, this is 0 or 1.
0.
This is also 0. 3 strings check చేయాల్సిందే. With 2 strings you cannot tell the answer, and also it is a non-overlapping condition. Now what about this?
1.
Right, perfect. So this is what he is asking. Now he is asking that, so please design a sequence detector which is going to check whether there are 2 or 3 ones. Now what is the difference between the earlier set of questions and the present set of question?
అంటే అంటే ఆర్డర్ ఇక్కడ ఉండదు సార్ ఆర్డర్.
Right.
ఎర్లియర్ అరేంజ్మెంట్ అంటే ఇక్కడ ఓన్లీ కౌంట్ గురించి.
Right. So here we are associated only with the count of ones. 2 ones ఉన్నాయా or is 3 ones ఉన్నాయా, ఇది మాత్రమే చెక్ చేస్తాం. We don't bother about the sequence whether it is 101 or 110 or it is 011. It doesn't matters. ఏది ఉన్నా కానీ అవుట్పుట్ is equal to 1 అయిపోతుంది. 101 or 110 or 111, and 3 ones is also there, triple 1. So 3. So this is the string which he is asking us to verify. Now how many combinations will be there? The indirect question. So indirectly it says that, indirectly if we analyze this, the meaning of this question is 3 strings అన్నాడు. So it is 0 0 0 0 0 1 0 1 0 0 1 1 1 0 0 1 0 1 1 1 0 and triple 1. All these are the possibilities. ఇవన్నీ possibilities ఉండొచ్చు. Now tell me for what cases we will be getting output as a 1. 2 or 3 ones అన్నాడు. What will be the output for this case? Combination 0. దేనికి 0 వస్తుంది. For this also we get 0, and for this we get 1.
1.
Right, for this we get 0, for this we get 1, for this we get 1, for this we get 1. So indirectly he is saying that please detect whether we are getting 011 or 101 or 110 or triple 1. For all these cases my output must be equal to 1. This is what we are supposed to design. So indirectly the hidden question is this. Right, so you need not design for this, you just design it for the question itself. So hidden question ఏంటంటే అది the meaning ఏంటంటే, so whenever it is 011 or 101 110 or triple 1, then my output must be equal to 1. Then my output must be equal to 1. Now for this you are supposed to design a sequence. You please try it. Now you need not do the 4th version, so I'll be sharing this PDF with you, so please try. Question number 3. Second problem. 4 o'clock you are having class, right? Class undi kada meeku? Right.
Yes, sir.
Okay, I'll be closing the session here itself, and I am sharing this PDF also. You check this also. ఇది కూడా check చేయండి. You try these questions also. You try the question number B చేయండి. You try this also. Right, you go through all the questions and you just try it. And try it. Right, from Monday onwards, so all the batches will have sessions on Verilog coding. Sessions on Verilog coding. And for mid 2, mid 1, of DLD, the syllabus will be first 3 units.
DST, sir.
Right, okay, DST. Mid 1 digital system design, so syllabus will be the first 3 units. The second unit will be covered on Monday, Tuesday and Wednesday. Verilog coding concepts will be discussed on Monday, Tuesday, Wednesday, right? Thank you. You may leave, and if you have any doubts, you may stay back and you may get it clarified. You may leave and you may join the other class.